Programming Throwdown, episode 84, Customer Bug Handling. Take it away, Jason.
Hello! Hey everybody, how's it going? Episode 84. This is going to be pretty interesting. I'm actually pretty excited about this. This is something that a lot of people, they don't really teach that well in school, and you could easily kind of get bitten by this. And I've definitely gotten bitten by it, and so we get to kind of talk about it. But before we do that, let's talk about some really funny computer science pop culture. So how many of you have seen some type of TV show, especially earlier on, like let's say the 90s, the early 2000s, and they try to talk about computers and computer science, and it's just such an epic fail. We've posted a few of them here. My favorite is, and definitely check out the website, programmingthrowdown.com, and you can check this out. But just spoilers here. The first one, they're trying to track some criminal hacker, and this woman's like, he's doing it in real time. And then this other lady goes, I'm going to write a GUI in Visual Basic to track his IP address. Dead serious. And then she just walks away. And I'm pretty sure at the end of the movie, that GUI saves the day. But it's pretty epic. And then there's a couple of other ones. Definitely check them out on the website. Who is this 4chan guy? And that's another good one. If you have any good ones, send them over to us. But it's no end of entertainment there. People have now even made playlists. There's whole playlists of all just hacking, hacking video fails. One other thing to mention, a lot of people wrote in about our last episode, which was the episode on teaching kids to code. And let me pull it up right now. There were some actually absolutely phenomenal suggestions out there.
While you pull that up, I'll give my contribution to this, which is I have nothing to say on computer science references, but I know this is a thing that other people talk about as well. Like I've seen YouTube videos from a biologist saying biology and video and movies is all wrong. Astrophysics is all wrong. I think Neil deGrasse Tyson does some about space travel and astrophysics and ruins movies, by pointing out how bad the plot is. And the one I saw recently was people complaining about how you learn jazz music. So I think this is a universal thing where movies try to take artistic liberty because you want to make an interesting movie. And I personally, people are like, oh, they don't know what they're doing, they're so dumb. But I don't know. I think personally it's just they might know, or they know they could go figure it out. Like, I'm going to make a Visual Basic GUI to hack his IP address. Yeah, sure, that doesn't actually make sense. But to 99.9% of people, that sounds the equivalent of Avada Kedavra. And it's like, oh yeah, you're just making Harry Potter spells. It's just an incantation. They don't need it. They're picking real words, but it doesn't have to be meaningful.
Yeah, that totally makes sense. Yeah, I think I wonder if now, because I feel like nowadays they're a bit better about that. So I wonder if they consult with somebody. It's just that when these shows were made, that was so kind of unpopular and passé that they just made stuff up. Because nowadays it seems much more legit. Like when I watch more recent shows.
That's right, and I think even in I think famously in the Die Hard movie, the bad guy is I'm forgetting it, either German or Russian. And that's what they insinuate. But he's just speaking, I think, just gibberish. And in the sort of German and Russian version, whatever it is, the bad guy is some other country, but he's speaking the same words because they're just sort of like gibberish words. I believe I'm recalling this correctly. But then someone was pointing out that in Game of Thrones, they actually consulted. There's a guy who's the Hollywood consultant for foreign languages or invented languages. He's like a linguist.
Oh.
And so in Game of Thrones, this Dothraki language or whatever is actually modeled after realistic languages. It's a whole language, it's a whole thing. And when they need a new word or sentence structure that they've not had before, they consult with him, and he helps them come up with a cohesive system as if it really were a language.
Wow, that's cool. Yeah, I think I recently saw the show Scandal, and my wife was watching it, and I was catching a couple episodes, and they had some hacking sequence, and it kind of made sense. I mean, it wasn't. I don't know much about hacking myself, but I mean, it definitely seemed a little out of place. But they had a bash command and they're doing, I don't know, ls, and they're going to a directory and looking at a file. It was like, it was much better than than the ones we posted, but also much less funny. But yeah, as far as teaching kids to code, Anthony wrote in. He had a ton of really amazing resources. One of them, which I actually have for my kid, but I forgot, is Kano. I don't know. Do you have a Kano kit?
No.
Or have you heard of this? So it's like this. It looks like about a Raspberry Pi with a case, maybe a little bit bigger than that. But it has like a little joystick built right onto the motherboard, and the joystick kind of pops out of the case. And it's also got some buttons, and you could they have like snakes and a couple of simple games, but you actually have to build the computer yourself. You don't have to solder or anything crazy, but you have to plug the battery in. You have to actually plug the buttons in. You have to kind of assemble the case and everything. So that was one he mentioned. Also Scratch, that's pretty popular. It's like a little graphical programming language. And then Betty wrote in, and Betty's actually a math professor at, actually I won't say the university just in case. I don't really know if people like mind us, revealing their identity or not. But anyways, with that in mind, I won't say where she teaches, but she's a math professor. And she recommended something called bricklayer.org, which looks really cool. So she actually founded it, and it looks like it has a bunch of different things for using Lego to teach kids math and things like that. So some really cool resources. I was actually really impressed that a math professor even listens to the show. So kudos to you, Betty, and also Anthony. Thanks for the heads up.
All right, man. Is it time for news? Links?
I think so. I completely lost. Do you want to do the first one? For some reason, I totally lost my...
Okay, no problem. All right, so the first one I have is running across an article about using, which apparently is built into both Excel, but this one and Google Sheets, but using the Google online version of Excel, the spreadsheet application, is being able to run simple SQL-like queries in it. I find it very difficult sometimes that I want to do something, and there almost always is a way to do it, of manipulating or filtering or searching for data. And so this points out that you can do some common SQL operations within a column in the spreadsheet.
Do you have to install something?
No,
or it's built in?
No, built in. It does not let you do joins, but it does allow for filtering, and it's in like sort of, to me, like the group by clause, the min of something, group by, order by, this is more not, I want to say intuitive is the right word, but it's more at hand to me because I've done that more recently. And so I'll link this, but this is from Ben Collins. And so there's some videos linked in even as well. To be fair, I didn't watch the videos, but I just looked at the examples and sort of got the gist. And so you can sort of say equals query, the column you want, select this other column, this other column, this other column, where, the whole thing. So I thought it was pretty cool. I had no idea. And then, apparently there's some stuff that works in Excel. So if you ever find yourself needing to use spreadsheets, I find is one of those weird things. There are many, many, many people who spend enormous amounts of time in spreadsheets. And really know what they're doing, when it's like a Python program probably could have done this way easier, but it's just what they're comfortable with. But on the flip side, I find a lot of times... I think
the GUI for Excel is just amazing. Like the user experience is so nice. I'm really surprised that more languages don't have something like Excel, where you can kind of just easily see everything and things like that.
Yeah. And I will say that for me, people from a CS background, though, I think sometimes underutilize. I guess you're sort of alluding to the same thing. But people from a CS background tend to underutilize spreadsheets. Because sometimes it really is fast just to dump a bunch of data into a CSV, open it up in Excel, Google Sheets, the OpenOffice. I'm not sure what it's called there. Numbers? No, Numbers is the Mac OS version.
There's LibreOffice, which is a fork of OpenOffice. That's the only one I know.
Yeah, but they have a spreadsheet equivalent, but I don't know what the name of it is in that suite. Do you know? Okay.
I think it's just called Sheets. I could look it up.
Okay, doesn't matter. And any of those, anyways, dumping a CSV, opening them up in there, and being able to do something really quick, depending on your data processing skills in Python, may or may not be faster. With stuff like Jupyter Notebooks and Pandas, that story is becoming slightly less awesome if you know how to use those tools. They can often be, almost as effective. Okay, spreadsheet. But yeah, anyways, if you do know how to use this or are stuck with some data in that format, check it out.
Yeah, it sounds awesome. Yeah, actually, there's RStudio, and that's the only thing. I mean, I guess MATLAB, right? I think MATLAB has a little spreadsheet type thing, but
I guess cell editing.
That's kind of like a sledgehammer, right? There really isn't a good, if you want Excel style where you just have all of your matrices are just completely visualized like that, like in those sheets. There's really nothing out there. I'm actually shocked. Well, actually, isn't there? There are some products, I've just never used them. There's Tableau, and there's another one, I can't remember the name of it, but I think people have done this. It's just none of them have gotten any popularity. All right, that's super cool. I'll have to try that out. My news is about deserialization issues. So, a lot of people might not have tried this, but in Python you have pickle, and in Java you have I can't remember. I think it's just called the Java serializer, and you have similar things in Ruby and things like that. And it's pretty amazing. Like in Python, you can actually you can pickle anything. So almost any object. If you try to pickle, let's say, a file pointer or something like that, you'll get an error. But you could pickle almost any object without having to write any serialization code. Like you don't have to, do a like concatenate a bunch of fields into a string and then figure out how to pull them back apart. It just does the deserialization for you. The serialization does everything for you, and it writes it to some binary file. So it seems kind of like magic. It seems really cool. The thing about it is it's so open-ended that, well, for one, it's not very efficient. So a lot of people don't really use it other than kind of, prototyping and things like that. Also, if the language upgrades, so if you go from Python 2 to Python 3, that could cause some issues. But on top of that, there's some real security vulnerabilities. And so I think that's, again, comes back to the whole fact that you could pickle almost anything. So there's actually a way where, and you'll have to read the article to get the details, but I think at a high level what's going on is, you unpickle something and it unpickles into, or basically someone has created, so you pickle a file and then you unpickle it later to get back your object, right? But let's say someone has access to that file and they can manipulate it or replace it with another file. Then you unpickle it and, thinking that it's the original file, and then just start using that class. But it turns out that person has kind of poisoned it. So for example, just a really naive example, let's say you could just pickle Lambda functions. So you could pickle a whole function with all the operations. And so, you have .x equals 3. So you have my class .x equals 3. You pickle my class. And so that file now says, okay, my class had an object X and it was an integer 3. Now someone comes along and replaces that file with one that says, oh yeah, my class had a variable called X and it was actually a function that, wipes your hard drive. Oh. And then later on you depickle that, unpickle that, and then call, my class.x and you lose your hard drive, right? So I mean, I don't think it's that simple. But at a high level, that's kind of what's going on. Is someone can actually inject really dangerous code, and when you unpickle, you get hit by that. But it's a cool article. They link to some other articles, so it's a bit of a rabbit hole, but you can follow the rabbit hole down to some really good presentations where people talk about it in detail, and they show you they walk you through examples of how exactly this can happen. And I just found this stuff fascinating. It's an attack vector that I didn't really realize was the thing until just now.
Yeah, serialization and deserialization are tricky and important to get right, especially if other people are providing you data.
Yeah, exactly. Yeah, I mean, anytime someone else is contributing data, you have to really expect just about anything. I have no idea why you would use Pickle for data that's coming from other people. Actually, maybe it's because you're unpickling crash logs. In which case, that might not be the right tool for that job.
So on a similar related topic, I actually think I got this on the programming subreddit, the stack sort a la XKCD. So there was an XKCD, I should have brought it up so I could link that as well. There was an XKCD article where they described an ineffective sort. And one of the ineffective sorts, is it here? No. There was one where they basically alluded to, let's see if I can find it. Where they alluded to searching for a sorting algorithm. Oh, here it is. Perfect, linked. I should have just gone to the GitHub page. No, it is there. So basically, the XKCD was showing crappy ways to do various sorts. So things like, pick a random number, and then at some point, like run various commands like rm-rf star, do just like crazy things. It was just sort of a joke, right? Like XKCD stuff. So this person tried to say, I know of a way to do an ineffective sort. We'll search Stack Overflow for how to sort a list in JavaScript. And we'll run the example code, like people put example code. So we'll find top voted answers where there's code, and then we'll try to run it and see if it sorts the list. And so if you go to the website, which is sort of super sketch, and it even like says, I'm going to pull some scripts from Stack Overflow and eval them. So like, hey, this is probably a really bad idea. You probably don't want to do this. But if you do, it goes and pulls it and then tries to see if it'll sort the list or not. So most of them turn out not to be runnable, but occasionally you'll run across one that will work. And so you just keep running them until you find that it's sorted. And so of course you could check if it's sorted. And then it's a little more clever though, because the first immediately obvious thing is to just start upvoting an answer that does something very malicious. Like uploading all of your browser history, or running you wouldn't mine Bitcoin, but running a cryptocurrency miner in JavaScript. And so you could do something really crazy malicious. So what he did was limit it to posts that came out before he sort of pushed this up, so that people wouldn't know that he was going to do that. Yeah. So that was at least somewhat thoughtful. So. Anyway, so I thought that was kind of like a good joke. Oh, that's what it was. My brain is not working this episode. I apologize in advance. So it was the alt text of the XKCD. So if you don't, this is something I didn't know about for a long time. I guess I'm not enough of an enthusiast. So there's like XKCD Explained website, I think is what it's called, where they explain some of the jokes, because sometimes it's not obvious, even like to me. But then a lot of times there's stuff when you hover over the image and it gives you the like explanation of what the image is supposed to be. There's this alt text, and a lot of times there's this funny alt text. So the alt text of the ineffective sort page on XKCD is stack sort, connects to Stack Overflow, searches for sort a list, downloads and runs the code snippets until it finds one that sorts the list. That's what the alt text says, and this person implemented that.
Nice.
Sorry, I completely botched the beginning of that story. But if you didn't know about this,
it's amazing. You should absolutely try that.
Or don't. Like, I'm not sure. Sounds immediately like a terrible thing to do.
Yeah, mine's a Bitcoin, sends it to Patrick, and then sorts the list. Takes a long time.
I did notice, while we mentioned Bitcoin now a couple times, that the number of times I overhear cryptocurrency being mentioned randomly at work while walking by has dropped, very strongly correlated with the drop in price.
Yeah, I mean, nobody's really talking about it anymore. It's pretty wild. Actually, they started cracking down on the browser-based miners.
I saw that, yeah.
Yeah, so there was an issue where there were some websites that were just mining cryptocurrency. So you would go to the website, and while you're on the website doing whatever you're doing on there, it's mining cryptocurrency. So one of the examples is actually BitChute, which we talked about in the past, which was a way to watch videos, kind of like YouTube. they were running a cryptocurrency miner, and they actually they posted in their blog that they just turned it off because of pressure. I guess their ISP is going to shut them down or something. But up until now, they've been just mining Bitcoin on your computer, which is pretty wild.
Yeah. So I don't know. So the reason why I said not Bitcoin is because I think Bitcoin from a CPU perspective is really bad now. But there are other coins which are still like designed purposely to work pretty well on a CPU still. And so I'm not sure the exact details. But I'm actually, that falls into, this is off topic, I guess. But it falls into a little bit of a murky thing. Because at some level, it's like if I go to YouTube and I'm watching a video for free, you can send advertisements. Or if you disclosed it properly, like not the whole time watching a video, but maybe for like the first 30 seconds that I'm watching a video, it's computing some hash, doing some work, whatever. And that's like the exchange for me being able to watch the video to like help offset the costs. Like at some level, it seems like it could be a reasonable business model. The issue is just doing it without people's consent. Seems a little like slimy, but I'm not clear why it became such a major issue.
I think if they had popped up a box saying, you have to agree to mine Bitcoin to watch this video, I think it would be a totally different story. Yeah.
Yeah, I guess I don't know. I don't know how I feel about it. People installing malware that does it on your computer, like obviously like sucks, right? They're doing something completely without your permission. And there were some malicious, I believe, Chrome add-ons and other add-ons to browsers where people were doing it as well, slipping them into, well, that was an article yesterday or 2 days ago where there was a Node.js package that checked to see if you have a wallet on the computer, and if it had a certain number of Bitcoins, it would get your private key and send it to a command and control server. And this like Node package was imported by lots of major projects.
Geez.
I mean, that obviously like horrible, right? And or putting some sort of obfuscated crypto miner in a package that you manage as an open source thing without telling anybody. Like, I think those things are all pretty bad. But yeah, in general, it seems kind of like a decent trade you could make. Like, I'll go to your website in exchange for donating some of my compute power.
Yeah, I mean, it seems fine to me. I mean, as long as, as you said, as long as the consent is handled correctly, I mean, I think it's fine. All right. My show topic is a retrospective on GraphQL. So we haven't actually talked a lot about GraphQL. I think GraphQL would definitely be a great show, and we should definitely. I'll add that to my list of things as I think about it. But just to kind of explain briefly GraphQL, it's a replacement for REST. So you typically have a REST API, and you'll have for example, you have a bunch of endpoints. So if I go to my website /API/me, it maybe returns some JSON with my information. If I go to /API/user, Patrick, then it gets his information if I have, access to it or whatever. And so you could build endpoints like this. But things kind of, especially for graph-based information, it kind of gets out of control. And it turns out a lot of things can be modeled as sort of a graph. So imagine you have email. So you have your inbox folders, and each of those folders have emails. Each of those emails have attachments. You can kind of see there's this sort of tree structure developing, right? And so you end up writing these really complicated query handlers for being able to return data. And typically, you end up needing to access different slices of data at different times. And rather than write, 10,000 query handlers, you end up writing one that returns more data than you actually need, just so that it can service, 3 or 4 different requests or different types of requests. And it just gets very messy. And so GraphQL is basically a replacement for REST, where you basically say, GraphQL, you own this part of my website. So it's like, /API/GraphQL. Like everything in there is owned by GraphQL. And then what they will do is it's just they will basically handle a lot of that for you. And so you can execute different queries, and you can ask for, certain pieces of information, and you'll only get back that information. It's really nice. I highly recommend it, especially, once if you're building a website that needs to kind of fetch data in that format. Like if you're building an email server, that's a great example. It's definitely a good thing to learn if you're doing anything web. And this company talked about their evolution from a REST API to GraphQL, what that was like, and they also have a list of lessons learned. So definitely give it a read. It's pretty interesting. They've been using GraphQL for 2 years, so they have a lot of different experiences. They have things that they like, things they didn't like, certain packages that they were using, things like that. And so yeah, if you're doing any web stuff, definitely check it out.
All right, I think it's time for Patrick's book of the show.
So we're gonna do something a little bit different. We didn't. There's not too much time between last show and this show, so I have to admit I haven't been doing much reading. Patrick hasn't been playing enough video games, so Patrick's gonna handle the book of the show, and I'll do the tool of the show.
So with the Thanksgiving holiday, I just didn't end up commuting as much, and so as I've attested before, I call it reading, but I actually mostly listen to the books. And so I instead was using a different book over the Thanksgiving break, and I decided, hey, this would be good to talk about on Programming Throwdown because it's very programming related, and that is a cookbook. And that was sarcasm. It has nothing to do with programming. This book is The Food Lab by Kenji. I don't actually know how you say his last name. I guess it's Lopez Alt. But I know him. I read about him when he writes for a website called Serious Eats. And although there have been more nerdy food websites that have been around in the past, this one is like a good balance of sort of like nerdy tech approach to doing things without it being a gimmick. And so he just takes like a more, what I would say like an engineer style approach to how to cook, where you'll see things like in traditional French. If you ever watched a lot of engineers talk about Good Eats, which was Alton Brown's Food Network TV show, where they kind of play the science of cooking. And it's sort of like that. Like, in traditional French tradition. Oh man, I'm really out of it. You're not supposed to wash mushrooms under running water because they would absorb too much of the water. And so you're supposed to use this dry brush and really scrub at them to get the dirt out because mushrooms are really dirty. But then, like, is that true? Like, that's easy to test. Just dump a bunch of mushrooms in a bucket of water for a while and then put them on a scale and see if they got heavier. And if they didn't get much heavier, then they're not absorbing water. But those things are, how would you say that? Those things are not even like acceptable to question because that's how people have done it for hundreds of years. If you're adhering to
taboo.
high cuisine, like what do you mean? Like you do it because you do it. And there's just no questioning of it. So one of Kenji's big ones, like he uses like like what about reverse sear? So if you're going to try to crisp the outside of a piece of meat, tradition says you always sear it first and then braise it or whatever. So like I'm going to cook the outside really hot and then put it in a pot in the oven and cook it really low. And is that better or worse than what they call the reverse sear, which is like cooking it low and slow and then searing it at the end? And so like that's easy. Just try it both ways and then make an objective call or whatever. But people just kind of don't.
And so they do this and they actually do measurements and everything.
Yeah. So this Food Lab is sort of his approach where he tries to say like, hey, if you want scrambled eggs this way, do it this way. If you want it that way, do it that way. Like the trick isn't this or that. It's just like, add a little bit of water and your eggs are fluffy. Why? Well, because the water turns to steam, and when the steam is escaping, it's at about the same temperature that the proteins in the eggs set, and so it makes your eggs fluffy because it sort of happens around the same temperature. So if you want fluffy eggs, add a little bit of water to your eggs when you scramble them. Just these like really sort of common sense. They're not really exactly food hacks, but just like I don't know. I sort of relate to. I feel like this is the kind of cookbook I want to read rather than this very fancy highfalutin thing where it tries to impress you with the you need the. I don't even know how to pretend to be that. You need 1 centimeter long julienned carrots, and it's like okay, great. Like no. So, anyways,
I'd much rather have a practical book that says like here are the things you already cook. Here's how to do them better.
Yeah. So and there's recipes for stuff I haven't cooked and good ideas, and I just feel like if I go do this, I'm more likely to know if it didn't work, that it was something I did rather than this is a bad recipe. So anyways, so that's the
cool.
Food Lab by Kenji Lopez Alt, and we'll have a link in the show notes. And similarly to the stack sort we were talking about earlier, I do find myself and my family, the internet is sort of weird for recipes because you just go to Google and you say like, French toast. And then you can find just whatever website appears at the top, you click it, and if it looks reasonable, you cook that recipe. And then in a week, you're like, I like that.
I didn't cook everything.
So I go that?
That's basically how I cook everything.
Oh, okay. But then if you like it or don't like it, what do you do again the next time? Because if you search it again, it's not guaranteed the same site will come up.
Oh, yeah. I mean, if I cook it and I like it, I bookmark it.
Okay.
Yeah.
But anyway, so I still like cookbooks. I have a series. I might have a couple shows where I recommend them because I kind of enjoy cooking as a hobby, I guess. I'm not particularly great at it, and I don't do it sort of all the time.
I think it's a great hobby.
I like it as a hobby.
Yeah, it's fun. It's something you have to do anyways, so you might as well make a hobby out of it.
Sure. Yeah. So that's my book of the show.
Very cool. All right, my tool of the show. My tool of the show is actually Software RAID Controller, or just using RAID in general. So, quick story. About I guess it was about a week ago. I turned on my computer that I have sitting behind the TV in the living room, and it told me that one of my hard drives failed. And sure enough, it just completely failed. Like no warning.
No.
Actually, my wife told me about a few weeks ago that she was hearing this kind of clicking sound coming from the computer. So there was a little bit of a warning, but then it went away, and then all of a sudden, the hard drive just spontaneously died. Fortunately, I had a RAID 1 backup, and so what that means is I actually had two 2 terabyte hard drives that were RAID 1. They were mirrored. So every time I would write a byte to one, it would write to the other one, and it's done automatically. So basically, the way this happens, I don't know how this works on Windows or OS 10 or anything like that, but on Linux, you actually, all of your hardware is in the /dev directory. So anything in /dev is not is of your hard drive or of your, I guess, file system is not a file. It's an actual pointer to some type of device or some type of engine like dev random or something, right? So your hard drives might look something like dev/SDA, dev/SDB for your second hard drive, SDC, so on and so forth, right? What the RAID controller does is it makes a new device. I think mine's called dev/MD0, and when I mount that device, it looks and feels just like a hard drive. So I can mount it to a folder, I can open it up, I can add files to it, et cetera, et cetera. But everything I do actually gets written to this RAID controller, which then writes it to both of the hard drives. And so you can check the file system for errors and stuff like that, just like a normal file system. And under the hood, they're doing everything basically twice, right? So yeah, I've had RAID 1 set up for years and years. And it chose last week for one of the hard drives to just completely bite the dust. And I have almost all my family photos on that RAID array. So, if I didn't have a RAID array, they would have just been gone. I mean, I probably have some on Google or something, but definitely the original copies, the original size would have been just gone. So I highly, highly recommend doing this. If you don't have a Linux machine, and you don't want to go the trouble of setting this up, you can buy one of these NAS devices. So there's a Symbology is one, Drobo is another one. And what they'll do is they basically run the RAID controller and everything for you. So you buy this box, it's running Linux. You can just put as many hard drives as you want in it, and then you can access it from other computers in your house. So it just stays on all day. And from your desktop, you can go to some network drive and set that up. In my case, I already have a computer that's running all day, just sitting behind the TV. So I set up my own. But either way, I highly recommend setting up a RAID array. There's RAID 1, which is total mirroring. So, you basically end up with half the capacity. If you have more than 2 hard drives, you can do some of the other things, like there's RAID 5, RAID 6, so on and so forth. Basically, I think the idea is that, as long as you have N hard drives, you can lose one of them. Like the RAID 5 is set up so that you can lose one, and as long as you don't lose another one while the remaining hard drives are recovering from the loss, as long as you don't lose another one in that time, you're okay. Which is, it's highly unlikely you're going to lose 2 in a row. So yeah, definitely set up RAID. It really saved me. I went to Amazon. I bought a new 2 terabyte hard drive. When it arrived, I plugged it in where the old one was. I told my RAID controller, hey, add this new device. It told me it was going to take 220 minutes to replicate. But even during that time, I could add files to the RAID array. Like, it's smart enough to just work, like be completely available while it's replicating and all of that. So it's pretty magical, actually, how it works. And it totally saved me. So that's my tool of the show.
Nice. Also, it seems brave that
do you have
didn't
anything
just
like that?
wait the 220 minutes. That's only like 3 hours, right? Like
yeah, well,
3 hours,
I was
40
kind of
minutes.
curious.
Oh, okay.
So yeah, I mean, I created a dummy file just to see what happened. And it was pretty dangerous, but I live on the edge, I guess.
Okay. Yeah, I have something sort of similar. Although I'll admit my NAS, the network attack storage I have, is RAID arrayed inside, but I sort of use backup between my desktop and it as the backup strategy, I guess. So I don't have like
that makes sense.
My individual computers aren't rated.
Yeah, that makes sense. Yeah, that's true. My desktop isn't rated. The only thing I've rated is the family photos.
Okay.
And I also have that backed up. So.
Yeah. And I assumed my NAS was hardware RAID, but it could be software RAID.
I don't think hardware RAID is a thing anymore.
Oh, really?
Because I was thinking about this. Like I remember in like early 2000s when you could get a hardware RAID motherboard.
Yeah.
But nowadays, the RAID uses such a trivial amount of CPU because of Moore's law and all that. I don't think you can even get a hardware RAID. I mean, or if you can, it's like for some super industrial setting.
I will defer to you.
Anyways. All right.
All right.
Well, that's my tool of the show.
We typically do a pitch for Audible. You like to support the show. We didn't recommend a book on Audible this week, but we have a history on the website of many books which are available on Audible. And if you've never tried Audible before, I think both Jason and I are subscribers. And so we both enjoy it and pay happily for our own subscriptions. But if you haven't and you would like to become an Audible member and get a free book in the process, you can go to audibletrial.com/programming throwdown and check out one of the many, many books that they have. And like I said, look in our show notes for many recommendations we've made throughout time. Short books, long books, funny books, happy books, sad books. I think they got something of everything there. It really is actually kind of overwhelming. And they have sales too. Like while you're a member, you're able to get other books on a discount price. So it's a pretty good arrangement. I actually like it.
Yeah, same here. I'm a big fan. If you don't want to support us on Audible, you can support us on Patreon. Or even if you do, you can support us on both. So Patreon is pretty cool. It's you can give up to $1. Actually, this is the last month before the Christmas show. Last Christmas, that was pretty ambitious. We really set out to give a gift to everybody. We were able to give a gift to everyone in the US and Canada. But we had issues shipping international, like shipping overseas. And so I'm going to think really hard this month about what we can do. I learned a lot. We learned a lot from last year. We have a ton of fans, which is amazing. But it also means that, logistically, there are things that we're not experts in that we either need to get some help with. We're definitely going to give out the T-shirts and all of that. We do that every year. And that's pretty easy. They drop ship for us. But I'm gonna figure it out. I'm thinking anything we buy online, they'll ship relatively cheaply. So I don't know if we can give something to everybody this year, but I'm gonna figure that out. Either way,
stay tuned till next time.
This is the last month. Yeah, it's the last month to sign up to be in the raffle for the T-shirts and whatever mystery prize we figure out. So go ahead and you can join. You can get a crack at the mystery prizes, and then you can leave. It's fine. You won't hurt our feelings. But also, while you're a Patreon subscriber, you get access to the Patreon RSS feed, which is the super fast download. Downloads way faster than you can listen to it. Very reliable and all of that. And you help support the show, which allows us to ultimately reach more people.
Well, I think it's time for the topic of the show.
Customer bug handling.
That rolls right off the tongue. This is something that is actually really hard to get right. So you think about this, you have all the code on your machine. You might even be cross-compiling. So you might even be running Linux, but building something for Windows or something like that. I mean, that could be really extreme, right? But you have all of that information. You might be able to build in debug mode. You end up with this enormous binary, right? I mean, you have all of your own system libraries, all of that. And so that makes debugging relatively easy. You can step through the debugger. You can do all sorts of stuff like that. The issue is what happens when you send your program to someone else, or you deploy your website, or you push a mobile app, and then all of a sudden you start getting reports that, hey, it locked up, it crashed, things like that. Like, what do you do then? And it turns out that question is not trivial to answer. Actually, it's actually kind of surprising that there hasn't been just something that just has solved this for everybody. It seems like such a fundamental problem, but I guess it's just so fragmented, the ecosystem, that's hard to really do that. Yeah, I mean, I think not just the fragmentation. I think that we were talking about a little bit before when we were preparing for the show, but I think the scale of things matters a lot too. And so I think in a video game where it runs on many, well, hopefully it's a successful video game, and it runs on many people's computers, where the individual users, I don't want to say like low sophistication, but they're not really supposed to be helping you debug your app, right? Like, it just is supposed to work. And you will almost guaranteed going to get crashes just because of the statistical, like the number of hours your game is running in aggregate across everything is like somebody's going to drop their, tablet or lose power on their PC while they're playing your game. That versus, this application I write is for a very important customer who has 10 people who use it, and it's part of a multi-million-dollar business, and they're very sophisticated. They're very invested in helping me fix my app. And if something goes wrong, I'm probably coming out to their site and, working with them to get it. All those, the spread there is just incredibly wide.
Yep.
So,
yeah. So, I mean, it's true. If you go to, if you have enterprise customers, and you can actually go on site, then there's a whole lot you can do there, right? But let's talk about the case in the beginning where you are, let's say, a video game developer, and you're sending your game out to people. They're paying, let's say, $10 for it, and you're not really going to be able to fly over to their house. So one thing to do is turn on debugging symbols. It's one of these things. I mean, you have to pass the -G flag in GCC and things like that. And so you might be tempted to build things in release mode, but I mean, honestly, disk space is cheap. Network bandwidth is not that cheap, but you can most of the time these debug symbols compress quite nicely, and one thing, and this is going to be an overall theme for this show, is you don't want to put yourself in a position where you can't debug the problem. Like, you really don't, you absolutely don't want to, push out a release binary, you get a bunch of crash reports that you can't really do anything with, and then decide, okay, now I'm going to, take out some of these optimizations, right? I mean, you can build with debug symbols and the opt mode, and it's not going to be that much slower.
I'll caveat.
Go ahead.
Sorry. I will caveat that a little by saying that in the start here, we're going to talk about a bunch of things as sort of a survey of topics. But we talked about this when we talked about don't roll your own encryption, that some of these things can have implications that are kind of big. So turning on debug symbols is very helpful when you're debugging, but you have to weigh the cost of people understanding more about your code. So if you're in something where you're distributing code that you don't want people to know what it does, or it has secret sauce in it, or a really great filter or whatever, which is not most people, admittedly, but there are certain cases where you're going to want to be very careful about, I give this to someone, but I want to limit their ability to understand exactly how it works.
Yeah, that's a really good point. I hadn't really thought about that, but I guess what you could do in that case is you could have, basically you could divide your code up into the secure code and the unsecure code. And, the secure code could be built without debug symbols and then as a static library and then just linked in to the unsecure code. But yeah, I mean, generally, unless, if it's the secret sauce, there's ways around that. But generally, you
just
want
be careful
to, and I think most of the time, the errors are typically, in the interface, in the high level part of the code, which is not, it doesn't generally have a lot of IP.
Yeah.
The other part is, you have logs. If you can, you want to leave those logs running. Ideally, you want, if you're using like glog or easy logging, in the case of C++, or using like Bunyan, if you're using JavaScript, any of these log tools, they all have log levels, even like the log4j if you're using Java. And you typically want to allow people to turn on verbose logging. So you could have some kind of configuration file, and when they set verbose to 1, they get all the verbose log, and then they can email that to you. You could have a button where when there's a crash, it automatically emails the logs, things like that. But basically, you want to have access to that information that you have when you're debugging. That's another way to think about it is if you don't have something when you're debugging, can you still triage the problem? If the answer is no, then you have to kind of plan for that, right? You have to assume that whatever crashes you're seeing, you're going to see similar crashes coming from other people. So, for example, when we were rolling out the first versions of the Eternal Terminal, we were getting tons of really bizarre crashes because it was running on Windows for Linux. It was running on BSD. It was, there's people so we had deployed it at the place where I work, and there was hundreds of people using it, and we just encountered tons of OS specific bugs that were like extremely difficult for us to triage because we didn't have any logs. We didn't have really any of the stack trace, any of the debug symbols turned on. And since then, we've kind of added all this capability. It's made a big difference.
I think with both...
go ahead.
I'm sorry. With both rolling logs and log levels, there's consideration. So on rolling logs, one of the things is you want to limit how much space you take up. But you need enough logs so that if something starts, dumping tons of things going wrong, you don't miss the thing that started it all, and instead only see the symptoms, which is a problem I've run into. Other things there you can be clever about is trying to be careful about how many of a given kind of error you're seeing. So often you start spitting off the same kind of error over and over again. And oftentimes it's the first one that's the most interesting. And so making sure you always capture like the first of a given kind of error, like sort of slightly smarter ways. And with log levels, being careful that logging has some cost. Spending time driving down that cost is important. And then making sure that you're not logging at such a high rate or in a part of code that is running at a high frequency that you end up costing a lot of computation time to do the actual logging.
Yep. Yeah, it totally makes sense. Yeah, this is something that, definitely before you ship a binary, you want to run it in verbose mode and just make sure that it isn't just completely blowing up the logs, because that can happen very easily. If you put a log inside some really tight for loop, just one log line can cause, just megabytes and megabytes of log to just start building up almost as fast as you can see it. Another thing is, definitely, handle crashes and things like that pretty gracefully. There's a bunch of libraries to help with this, but basically you want to, catch the crash and typically what will happen is you'll try to get the stack trace. So in the case of Linux, there's actually a system call called backtrace that will give you the function pointers of the whole stack up until where you are right now. And so you'll want to run backtrace and then dump that to a disk to file or something, or to a log or something like that. In addition to crashes, I mean, crashes are the most common thing that you'll want to handle. But also there are signals. So for example, if you divide by 0, well, depending on the programming language, but I think in C you might get an exception. But I'm sorry, in C++ you might get an exception. But if you divide by 0 in C, you're not going to get some type of exception. There isn't even a concept of that. You're going to get what's called a signal. And you can look up the different signals. There's sig abort. There's sig sev. And what you want to do is look up all these different signals and make sure you're handling them gracefully. Like some of them, like sig interrupt, you don't really want to handle because that's only for when you're debugging. Or if someone hits Control C on your program, maybe just leave it up to them. But definitely the big ones like sig abort, sig sev, and maybe sig term when the process when something external tells your process to terminate. You want to handle those and catch those, and again, write a log out really quick or something like that. So then on the other end, now you've dumped all these logs. You have some way of getting these logs to some server that you own. Maybe use GraphQL for that or something else. And now you have to process all of those logs, right? And you don't want to be, especially if you have let's say 20 or 30 bug reports which you feel like are the same bug. You want to be very efficient at sort of going through those logs and picking out the most important pieces. Maybe you even want to write something that will pull the stack trace and dump it to a database. So you just have a database full of stack traces. And so this, I think we've talked about this many times, but become an expert in grep. Grep will absolutely save you. Grep is basically a way for you to just search for specific words in files. If your stack trace log line starts with stack trace : you could grep for stack trace : and you'll just see all of the stack traces and all of your logs. It's getting more common now to actually write logs as JSON objects. So like Bunyan does JSON. A lot of people now are starting to use JSON. And so you could use JQ, which is stands for JSON query. And it's similar to grep in the sense that you can say, just fetch this one object inside of this JSON object if it exists. Or you could say, give me all of the keys that start with this. And so definitely become proficient with JQ. The other part that's really important is, when you get again, the people who are running your code, they don't have your code most of the time, right? So they're running your game or your app or your program, but they don't have the original source code, right? But when there's a crash, you want to know the line of the source code so that you can debug, right? So what you have instead are you have these pointers, these function addresses, and the addresses map to lines of code, right? So so every function address maps to the start of a function in some source file, right? And so you can use, there's on Linux it's called ADDR2line. On OS X it's called ATOS. I don't actually know what it is on Windows. I'm sure there's something on Windows.
No.
Okay, yeah, but these tools, what they will do is, when you run backtrace on Linux, as I said, you're going to get a list of these pointers, and you can dump them to a log, let's say in hexadecimal, right? Then on your side, when you get this stack trace, you're going to need to convert that into the lines of source code, and that's what these tools do. So these tools take in the binary, and they also, I think you run them from the directory that has your source code, or maybe it's from the directory that built the binary. You have to look up in the manual. But basically, you'll run it from a place where they know where your source code is. They know where the binary is. That's another thing is when you ship the binary, you're going to want to basically know, get your source control tagged. So if I ship, let's say version 1, I want to tag my source control repository and say, this is version 1. This is exactly what every source file looks like. And here's the version 1, binary. So then if you get a crash back, you can load that version 1 binary. You can download that. You can get the pointers from that stack trace. And using the correct version of the source code and binary, you can actually recover the lines in the source where that person was when they crashed, right? So without this, you're going to be totally lost, right? I mean, someone's going to say, hey, my program crashed, and you'll have to kind of say, oh, what were you doing when it crashed? Like, I mean, it's impossible, right? You don't want to do that. So with something like this, they'll say, oh, my program crashed. You say, okay, give me the stack trace, and you're going to get this list of hexadecimal numbers, and you can pipe that list into address to line, and it will actually tell you the specific lines that the person was on, and you can follow that all the way up to main. Like the furthest one will always be the int main that starts the program. So if you're running, if this is like a Python program, then you don't really have to worry about that. But that also means you're sort of basically kind of distributing the source code. In that case, right? I think you could use something like PyFreeze, like one of these compilers. But I think even in that case, it distributes the source code. So yeah, I don't think there's any way around it in Python. Now, obviously, if you're giving people the source code and the binary, you could even run address to line on their computer and then just send you the location of the crash. But for most of these languages, like even Java, you'll have to unwind the stack, and I don't think you have to use any special program in Java, but you'll have to handle that.
Yeah.
So I think we covered, that's pretty much desktop in a nutshell. The hardest part there, as I said, is the crash handlers. There's a lot of, if you just look up GitHub C++ crash handler, you'll find a bunch of really great libraries to help you out.
And I think it's definitely something where if you're going to ship, you also want to practice it, if that makes sense. So introducing crashes and making sure that your logging is actually working as intended, because nothing's worse than a very rare crash happening and the logging isn't configured properly and you don't have what you need.
Yeah, actually, I can't remember. Oh, I think it's Android. And I don't know if it's in the modern Android, but there was definitely a version of Android, or maybe I'm mixing things up here. But there was something I saw where basically you could cause a crash. Like there was just like a expert menu, and you could go into a developer menu, developer settings, and one of the developer settings was crash. and I just, out of morbid curiosity, I tapped it, and yeah, it crashed. And you definitely want something like that in the first version, where hopefully you bury it way down in the menu, but someone who's helping you out can go hit the crash button, and you should be able to get a crash, and you should be able to trace exactly the line that crashed, and what functions called into that function, so on and so forth. So now for the web, if you're building a website, there's two components: your client and your server, right? The server is pretty straightforward, because on the server, it's you own the code, you have the binary, all in one place. Even if you're not developing on the server, you can always push the code to the server. And so that's not really that, let's say, interesting. You could even be running like a totally interpreted language like Python or Ruby or something. It's much more interesting when you get crashes on the browser, right? Now, this isn't, literally crashing the browser, because that's always Chrome's fault. If you can crash the browser, that's pretty much on them. But if your code causes an exception, that's typically the thing you got to watch out for. So, for example, you're getting the mean of a list of values, but the list is empty, and you divide it by 0 or something like that. So in this case, your browser JavaScript will throw an exception, and you have to handle that. And so typically on the web side, the way this works is, because the JavaScript is, because the source code of the JavaScript is sent to the browser, you don't have to worry about address to line or anything like that. One thing you do have to worry about is is the demangling. So if you do, for example, you run like one of these scripts that compresses your JavaScript code, it might take out all the new lines. And then now, big surprise, every crash happens on line 1, right? So typically JavaScript, when you do one of these compression tools, it'll create what's called a source map, which the source map basically just says, column 40,000 to 40,030 actually maps to line 3004, and so on and so forth. And the source map is just this huge file that maps, chunks of that enormous one-line JavaScript file to the original, file name and line. So it's actually similar to address to line, conceptually. And so there are tools which will, take the JavaScript stack trace of the one-line file and convert it into the appropriate stack trace that's readable. So you have to deal with that, but basically it's a similar idea where when there's a crash, because it's a website, you don't have to worry about how to get the crash to the server because you already have like a client server, framework in place. You just use whatever you're using to send data between those two machines. So use Ajax or even WebSockets, whatever you want. But then on the server, you'll have to do some work. On mobile, it's very different. So I've linked to a couple of libraries. For Android, it's ACRA, and for iOS, it's KS Crash. And yeah, basically, these libraries will. It's more similar to desktop than to web, right? So these libraries will send crash logs to some endpoint, that you have to set up. Sometimes they can even send it through some iOS or Android infrastructure, and then they'll arrive in the developer the developer store, the developer platform or front end. You can collect these crash logs. But I think in the case of Android and iOS, it's much more handled by the actual app stores. So I know I made an Android app a while back. It's been probably 6 years, but at that time they had a set of crash reporting tools. So I would just get a list of crashes, and they would provide the stack traces. So they would do a lot of that for you. So I think definitely take a look at what the Play Store can do, what the iOS store can do. But here's a couple of libraries that streamline that and make it even easier.
I've not developed much on mobile, but I feel in some ways mobile might be the easiest because even though there's lots and lots of mobile devices, it feels like there's far less than the number of configurations of computer hardware or web browser configurations. And so I feel like the number of your ability to potentially be able to replicate the issue might be much higher.
Yeah, that's a really good point. There is, let me see if I can find it. There's a really good tool which simulates different browsers. I won't look it up now in the interest of time, but if you kind of Google around for, I think it's called a browser simulator. But basically, literally on the left-hand side, it has a panel, and you can choose like Chrome, Firefox. I'm sure it can't simulate everything because it's just trying to run your JavaScript kind of through this middleware layer. It's not literally executing different browser code. But it'll try its best to, at least for CSS and things like that, catch a lot of those issues. But yeah, you're right. I mean, browser is in a sense the worst, although things are kind of homogenizing now, where I think Chrome, Brave, Firefox, it's most things now are kind of pretty cross-platform.
Cool.
Well, yeah, definitely send us your worst debugging nightmare where someone has a crash and there's absolutely no way to replicate. We always love hearing stories like that. I've definitely caused more than a few of those myself, so this is why it's what inspired this episode.
Yeah.
And hopefully with these tips you can kind of avoid doing it. You could set people up where if they have a crash, they can send you some information and you'd be able to triage. One thing, definitely expect everything to crash. Like if whatever you write, you have to have some way to handle crashes, either as Patrick said, because of different client software, Sometimes there's people who are running, Windows XP, and you'd be amazed. Like even the simplest programs don't work. People just do things you don't expect. There's situations you don't expect. There's internet, like some people's internet connection are not as reliable, and it's very, very hard to plan for all of these things. So you should definitely expect failure, and have the right way of like ideally automatically just sending some information to you. Cool. That's pretty much all I have.
All right. Till next time.
All right. Next time is the Christmas show. And actually, for January, we have a special guest. This might be our...
Hopefully.
Nothing,
hopefully.
Nothing against... Yeah, that's true. Actually, I won't spoil it. But we have an amazing guest. Hopefully. And I'm really excited. Definitely, it's gonna be absolutely phenomenal. We're going to start the year off extremely special way. But next month, we're going to have our Christmas giveaway or holiday giveaway. And, we'll hopefully give out some really cool t-shirts and some other prizes.
The intro music is Axo by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share-alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.